This is 4th grade, Module 3, Lesson 21, and in this lesson, students are going to continue solving division problems, this time with remainders, and we're going to continue practicing with the area model and connecting that area model to the standard algorithm. So why are we doing that? Why are we kind of bouncing back and forth between the standard algorithm and various models? Well, it's because we don't want that standard algorithm to be something that students just simply memorize without really understanding what's going on. So we're going to go back and forth between the standard algorithm and that, in this case, the area model, to make sure students understand why the algorithm works the way it does. As a point of differentiation, if your students really, some of your students really understand the standard algorithm, they get it, they don't need to continue going back to that area model, that's fine. Allow your students to simply continue practicing the standard algorithm.
So it says here to solve 79 divided by 3 using the area model. And I thought I would show you, I chose this problem because I thought using the area model to represent division would be a little unique for our parents and our teachers, given the fact that they probably grew up not learning how to divide this way. So I thought I would show this. So 79 divided by 3. So the idea is to think of a rectangle, and because we're dividing by 3, that means the height of the rectangle is 3. Now the idea would be, how wide is that rectangle going to be? And we're going to think in terms of tens, multiples of 10. So if we go 10 wide, that would give us an area of 30 square units. So I'm going to make a little mark here. There's 10 wide. But that's only 30 square units, and we want to get up to, but not past, 79 square units. So we could do another 10 right here. And now we have 2 tens. So 2 tens times 3 is 6 tens. So this is 60 square units. And if we were to do another 10, that would give us, let's see, 30, 60, 90 square units, and that's too big because we only want to go up to but not past 79. So that means we're going to stop here at 2 tens. Now you could think of this as 2 tens. I prefer to think of this as 20. And so our rectangle currently has a width of 20, which means if it has a width of 20 and a length of 3 units, that means the area is 60 square units so far, and we're trying to go up to 79. So we're going to do a little bit of subtraction here. We're going to do 79 minus 60. That gives us 19 square units left over. So we're going to keep going, and we're going to extend this rectangle. Well, we know we can't extend it another 10 because that would be 30, 60, 90. So we're not going to extend it another 10. Now we're going to think of, let's see, 3 times 1. Well, a width of 1 would be 3 more units. Well, we need to go up to 19 units. So a width of 2. So that would be 3 by 2, and that would be 6 units. And we're going to keep thinking about what is this width going to be until we realize, oh, if it's got a width of 6 units, and then of course the height or the length is 3 units, so a length of 3 units, a width of 6 units. Notice it's not really proportional, but that tells us that we have an area of 18 square units. And right now, we had 19 left over. We just used 18. So we have 1 little unit left over right there. Boom, there it is. And so what does this tell us? This tells us that the answer is, let's see, 79 divided by 3 gives us an answer of 26 because the width is 26. And we have a remainder of 1. Here it is, right here, that 1 little unit left over. Now, how would we show this using long division? Because it says we're also supposed to show this using long division. So the idea would be we would say 3 into 79, or another way to say this, probably more common, is 79 divided by 3. So the idea would be, well, this is 7 tenths. And right here, the best we could do was get up to 6 tens. So that means we're going to have 2, a width of 2 right there. So we know that, let's see, I'm grabbing my pen here. 3 times 2 tens gives us 6 tens. And that's this right here, 6 tens. And when we subtract, we get 1 left over. But then we also have these 9. When I said 1, that's really 10, huh? That's 1 10 left over plus these 9. So now we have 19 left over. That wasn't a 1, that was a 10. That was a silly move on my part. So now we have 19 left over, and that's what we had over here when we subtracted. Now if we have a height of 3, what can our width be so that we can use a maximum number of our units, our square units? Well, our width is going to be 6. So that means 6 times 3 gives us 18. And when we subtract, we have 1 little tile left over. So here's our 26, here's our 26. Here's our 1 remainder, and here is our 1 remainder. So it says Paulina solved the following division problem by drawing an area model. And then the first question is, what division problem did she solve? So the first thing we're going to do is we're going to fill in some of the missing values here. We know that if the area is 40 and the length is 4, that tells us the width must be 10. This width must be 10. And then this width right here must be 4, because the area is 16. If the length is 4, that means the width also must be 4, because 4 times 4 is 16. And so this part isn't really part of the question that they're asking. I just wanted to fill that in. The real question they're asking is, well, what did she solve? What was the original division problem? Well, the original division problem is 40 plus 16, so plus 2. So 40 plus 40 is 80, plus 16 is 96, plus 2 more is 98, and then she divided by 4. Now it just so happens we know that the answer happens to be 24 remainder 2. How do we know that? Well, because here's the 24 and here's the remainder 2. Now, next question is, show how Paulina's model can be represented using the distributive property. Well, the idea is going to be, using this drawing up here, we're going to start with, here's one way to do it, 98. 98 is represented as 40, 40, 16, and way over here, I'm going to put, here's the remainder 2, all right? And so the idea is this first 40, we can think of this 40 as 40 divided by 4 plus, and then right here, 40 divided by 4 plus, and then this is going to be 16 divided by 4 plus, well, I'm going to leave that alone right there. And then, so then we have 10 plus 10 plus 4. So here's our 24, and then here is our remainder 2. Now that's not exactly how the Eureka math shows the distributive property, but this is pretty darn close to, is good enough. Because to be honest, this concept of representing the division as a distributive property, pretty unusual. Although we can show you what it would look like in an upper grade. In an upper grade, we might take 98 divided by 4, and we might represent it as, let's see, 40 over 4 plus 40 over 4 plus 16 over 4 plus 2 over 4. So if we added 40 plus 16 plus 2, we would end up with 98. And then this equals 10 plus 10 plus 10 plus, now this right here, we're just going to leave it, 2/4. Whoa, this is 4 right here. And so now we can add them together. You get 24 and 2/4. Now, parents and teachers, we're going to actually do this in a future module in 4th grade. So if you prefer, instead of thinking of it like this, if you want to notate it like this, you're certainly allowed to. We're going to solve this using the area model, and then we're going to show how it looks using division. So let's start by doing, let's see, 54 divided by 4 means our area, our rectangle is going to have a height of 4, or a length of 4. Now what's the width? Well, if we do a width of 10, that gives us 40 square units. And we can't go any further because then in terms of multiples of 10, we can't do another 10 because that would go too big. And so what are we going to do? Well, we're going to take the 54, we're going to subtract the 40, and we get 14. Now what would that look like if we did the long division technique? We're going to do this side by side. So we've got 54 divided by 4, and the idea would be, well, you have 4. We want to go into that 4 as many times until we get up to 5 tens. We could go up to 5 tens, but we can't go beyond 5 tens. Well, that means we're only going to have one set of tens. So we've got 1 times 4, so 4 times 1 10 gives us 4 tens. And when we subtract, we get 1 10, plus we have these 4 ones left over. So I'm going to bring those, and so now we have 14 ones left over, and that's what we had over here, isn't it? So now we have 14 ones left over. Let's see, 4 times 3 gives us 12. That's as good as we can get without going over our 14. So 4 times 3 is 12. Let's see. So I'm going to take that 14, I'm going to subtract the 12, and I have 2 left over. So that's going to go right here. There's our 2 left over. So what is that going to look like over here with a long division? Well, we have 14 square units. We have a length of 4. So what is our width going to be? Well, our width is going to be 3, because length of 4 times a width of 3 gives us 12. We subtract, and we have 2 little units left over. So let's connect this. We got a 13 here. Where did we get 13 from? Right here. We got a 2 left over, and I also have it up here. We have 2 left over. Where did that come from? It came from right here. And the last problem for this video, 97 lunch trays were placed equally on 4 stacks. How many lunch trays were in each stack? Well, a tape diagram would look like this. You've got, let's see, 97 lunch trays, and they are stacked equally into 4 stacks, but it does say how many trays are going to be left over, so we might have some left over. That's kind of a rough idea of what the tape diagram might look like. So let's use long division to solve that. So we're going to do 97 divided by 4. Well, let's see. We have 9 tens, and we have a length of 4. So the best we can do is have a width of 2 tens. So that means we're going to use up 8 tens, and we subtract, and we have 1 10 left over. But then we also have these 7 ones. So we now have 17 square units left over. So the length is 4, what can the width be? Well, the width can be a 4. So that means a length of 4, width of 4. 4 times 4 is 16. We have one little unit left over. So our answer is 24 remainder 1. So how many lunch trays are in each stack? Well, the answer is 24. There's going to be 24 here, 24 here, 24 here, 24 here. And how many left over? Because that's not exactly 97. There's going to be one little lunch tray left over. And that's what 24 remainder 1 means. And that wraps up 4th grade Module 3, Lesson 21, solving division problems, still kind of using the area model, but we're continuing to connect that area model with the long division technique.